For the past 6 decades, everything in our life has had significant improvements, from the entertainment to the cars we drive to the planes we fly on. With the exception of how cities operate, the City Council of 1962 is essentially the same as 2022. We might have a large screen TV or data accessed by GIS. Other than that, it's essentially the same. So if you ever question why land development never seems to progress, the basis of all land development is coordinate geometry. Before computers, we would take a plan on a table, put a coordinate at a beginning point, look at the angles, and then add the distances up in our head, and then look at the angle. In a logbook, we would find what the sine of that angle, and then take that number times the distance in our head and get the difference of the northern coordinate and add that to get the next north coordinate. We would then take the cosine of that angle, add those distances together to get the east coordinate. If we didn't want to make a mistake, that would be 5 minutes. All CAD and GIS software only automates past methods. Let's talk about stagnation. There is no R&D for suburban neighborhood design. When we look at home sales and car sales, the two major products in this country, 3% of the gross product of auto sales goes into research and development. In suburban design, there's 0%. When we look at Rick Harrison's design studio for the last 30 years, and you could search on the internet, as far as suburban design, we're the leaders. The basis of all land development economics up until now has been density. How many lots can I jam into the site, whether it's the developer or the technician serving the developer? And the result is your typical subdivision. There's unintended waste because of this. And what do we mean by that? It's streets that are not fronted on both sides. It would be a street, in this case, these streets, 4,500 linear street. That's 50% waste. In other words, a lot sides one side and a lot fronts the other side. Here, the red street, there are no lots fronting it, so that's 100% waste. Now, there is waste in the cul-de-sacs, but for this exercise, we're not going to include them. Now, we just developed land in Rochester, Minnesota, and our cost for a linear foot of street was $1,622, and that's what we're going to use. So in this development, we have 2,700 linear feet of street waste on the one-sided street. Times $1,622, that's $4.38 million. But because we had the waste, we had to dedicate that land back to the city that we really didn't have to dedicate. So that's 3.09 acres at 50 foot wide. We'll assume $160,000 an acre for entitled land is another $500,000. So when you add it up per the 244 lots, there's $20,000 in waste per lot. So what if a new technology allowed us to have new geometric models that breaks the law of minimums? In other words, that law is density is based at the lot width at the front setback. More street length equals more lots. More street equals less space for lots. But if the setback line does not parallel the street but is greater than the minimums, the paradigm shifts. A more organic streetscape results. Now let's take a look at applying that to the subdivision. Now, when you look at the after plan, and this was designed over 2 decades ago, we had 42% less street length, 40% larger lots, and we did have 2 less lots. But if you look at the geometric modeling, it would have taken years to manually calculate this freeform design. And that is why technology allows us to go a step further than we ever have before. Let's take this at a much larger scale on this development in Vieira, Florida. The original plan had 44,000 linear feet of street. When we look at the redesign of a much more efficient street pattern, we reduced the streets by almost 17,000 linear foot, or $27.2 million less in street construction. For the 703 homes, that's $39,000 roughly per home. Now we take the 19.2 acres that we didn't have to give to the city times they assumed $160,000 an acre. So that's another $3 million the developer didn't have to just gift to the city. You divide that by 703 homes, that's $4,200 per home. So in other words, we have almost $43,000 per home of funds that can use for better architecture, better landscaping, lower prices, and creates a better product. While we're on the subject of merging architecture and planning, let's take a look at the garden villas at the ponds at Highland Hills, otherwise known as bay homes. We have a zero lot line style lot that allows a private side yard in these association maintained units. The side parking allows less space between the garages. So in other words, we have the same or more parking and we're utilizing that side yard that's normally underutilized. All bay homes have a full front porch and they all are staggered for a panoramic view of space. The interior floor plan is coordinated with the exterior plan. Paved space plummets per home because it is an alley type home, but we're not necessarily building a street in front. So we're much more efficient home, much less cost to develop. And the park cars are visually screened, so it's also a very good low-income solution. And when you look at the design, they are 26 to 28 foot wide in this example, but they appear to be much wider because of the staggering allows the architecture and the facade and the presence to be much greater, the visual impact. But the big thing is this panoramic view, the enjoyment of space within the living areas of each home. And we could do that by blending architecture and planning.